Welcome to Izzo Math. This morning we are going to talk about trigonometry and right triangles. Most of you probably remember this from high school. It was probably what you remember most about trigonometry from high school. And that is given, so we have a right triangle here. Okay, so right triangle, and we have some angle theta there, and we call this side A, call that side B, and call that side C. We know from high school, let's say that's cosine of theta. Cosine is the adjacent side. This is the adjacent side. So A is the adjacent side to theta over the hypotenuse. So cosine theta equals adjacent over hypotenuse, which equals A over C. Let me do sine theta in a different color. Let's go to here. Sine theta equals, and it's going to be opposite, and that's going to be B is the opposite with respect to theta. It's the angle opposite of theta. Opposite over hypotenuse, which is going to equal, so again, opposite over hypotenuse, B over C. Tangent theta, it's going to be yellow. Tangent theta, again, is going to be our rise over run. So it's going to be our slope. It's going to be the slope of that line there. So it's going to be the rise over run, or opposite, which is my rise over my run. Opposite over adjacent. Which equals B over A. And some of you probably remember SOHCAHTOA. SOHCAHTOA. Okay? So this is sine equals opposite over hypotenuse. Cosine, so that's sine. Cosine equals adjacent over hypotenuse, and tangent equals, so that's the tangent, equals opposite over adjacent. SOHCAHTOA. That will help you memorize how to find those. But what I want to do next is talk about why this is true based on the work that we have already done. Okay? And now before I do that, I want to make a little excursion here into similar triangles. So if we have two triangles, here this is again from high school geometry. It's probably proved in Euclid's Elements. Book 5. I'm currently working on book 2. Anyway, let's say we have an angle here, some angle theta, and that this is the same angle here, okay? And both of these are right triangles. And let's call this side A, B, C, and let's call, let me go back there. Let me call this big A, big B, and big C, and let's call this one little a, little b, and little c. Okay, these are similar triangles. And how do I know that? They have, if this angle is 90 and this angle is theta, then I know this angle up here is going to be 90 minus theta, or let's 90 minus theta, or pi over 2 minus theta if we're in radians. Okay? So clearly So that angle is going to match that angle because we're going to get it in the same way. So we have similar triangles. And so what does similar triangles tell us? It tells us that if we take the ratio of corresponding sides, we always get the same thing. And what you can really think of this is there was some scale, some number that I multiplied big A by to get little a. I multiplied big B by that same number to get little b, and I multiplied C by that same number to get little c. Again, this is pretty heavy stuff. Similar triangles is so useful and it's so cool, and it kind of seems simple, but it truly is one of the most useful things that you will learn about proportions. So what we get is that C over C, because I had big C over little c, I had to multiply C by some number to get little c, but I multiplied big B by the same number to get little b, so their ratio is the same. When I divide C by big C by little c and big B by little b, I get the same number. We get that factor that we multiplied by. And the same goes for big A over little a. And you see that you could also rearrange these just using math on these. You could do things like big B over big A equals little b over little a. Anything when you're doing so, that is big B over big A equals little b over little a. That's true. You could also do something like what? C, let's see, we could do anything we want. We could do C, little c over b equals big C over, so little c over b equals big C over big B. So that was little c over b equals big C over b. You see, as long as we do corresponding sides there in our ratios, we're always going to get the same ratio. We're going to get that factor. So what we want to do is use this, and let me show you how we use this. So for example, in our previous studies that we've been working on in trigonometry, so we have an angle here, theta. Okay? We know that this bottom side here is cosine theta, and we know that this side is sine theta. Okay? And we know that the length of the hypotenuse is 1. So what you might ask is, what if we have some triangle, let me go in green here, what if I have some triangle that has the same angle theta, no, it's 90 degrees there, just like our first triangle was. How does that relate to the sine and cosine of in our unit circle? So let's call this side A, let's call this side B, let's call this side C. Okay? Now note that we have the same angle theta. Okay? And thus that's going to leave us with this top angle being pi over 2 minus theta, or 90 minus theta. And both of them, so they're both the same because we have a right triangle there. So what we have is similar triangles. So let me go on white. So we have similar triangles. And so by similar triangles, we see that, let's say cosine theta over 1. So cosine theta over 1 equals A over C. That's going to give me that cosine theta equals adjacent over hypotenuse. Okay? We see that sine theta over 1. Sine theta over 1 is going to equal to, by similar triangles, is going to equal to B over C. And that would tell me that sine theta equals opposite over hypotenuse, just as we had before. How are we looking on time? 10 minutes. Last one, let's see if I can get this one in. Tangent theta equals, well, sine over cosine is tangent theta, which equals B over A. Sine theta over cosine theta. So sine theta over cosine theta by similar triangles equals B over A. And tangent theta equals opposite over adjacent. And I'm going to sign off here quickly, hoping that YouTube will let me post this video. I hope that helped you out in relating what you knew about right triangle trigonometry to how we've really been focusing on the unit circle trigonometry. See you in the next video.